Hello and welcome to another tutorial of SystemVerilog in 5 minutes. Today we'll be talking about class pointer. Let's look into a real-life analogy. There are many people in the world. Everyone can open up a bank account. We can create an ATM dedicated for every account, but we know this is unreasonable. In reality, we may have only one ATM and every user takes turn to use it. The ATM is not a user account. It simply points to the account as requested by user. We can add another ATM to increase convenience. When an ATM is not in use, it does not point to any account. Now let's get back to SystemVerilog. This example contains two int variables a and b. A is assigned to 1, then b gets the value of a. This is the same example with two handles of C number. This is the C number code. You need to remember this class as we'll be using it throughout this video. First, we instantiate the handles, then we can change the value of the member I in CA. Similarly, we can copy CA.I into CB.I. Now, can we copy CA to CB like this? And if we can, what does it mean? Actually, CA and CB are pointers. At first, they don't point to anything. This is the same as an ATM which is not in use. When you call new, an actual variable is created. The actual variable is commonly known as object. We modify the object through the pointer. This is the same as using an ATM to access the bank account. CA and CB are the ATM and object is the account. This line changes the CA.I. This line copies CA.I into CB.I, and this line is the focus of this video. Basically, it copies pointer, which means CB points to what CA is pointing at. That's the same as using a different ATM to access the same account. A special note here, the object which is no longer in use will be released from memory, a process known as automatic garbage collection. Now let's look into some examples of using handles. This is a simple array example. There is an int a and an array q. In the loop, we change the value of a and then we put the value into the array, and we do this several times. This is the same example but with C number. There is a C number handle a and a C number array q. First, we need to instantiate the handle a, then we can change the value of the object, and then we can put a handle into the array. Now we change the object for a second time, and a second handle is being put into the array. However, the handle is pointing to the same object as a, because that's what copying handle means. In fact, Q0 and Q1 are pointing to the same object as a. If we do it again, the behavior is the same. At the end, even though we have an array of 3 pointers, we only have one object. This is the wrong way of using array with pointers. The correct one should be that the constructor is called inside the loop. In the loop, a new object is created. We change the value of the object, then we put a pointer into the array. We create a brand new object and repeat all of this again and again. At the end, there's an array of 3 pointers, each pointing to its respective object. Now another example, task call with class handle. First, we instantiate the pointer, we change the value in the object, and then we call the task, passing in the handle as argument. As such argument arc will point to what Cn is pointing at. When arc changes the int I to 2, Cn will know about it. And this is somewhat similar to a ref argument, but it's not, because arc is a different handle after all. It can call new by itself, and if it does, it will create a new object. When arc changes the value of the new object, Cn will not be aware of that. In general, it is not a good practice to pass in a handle as argument and then use the argument to create a new object. This is the same example but with an output argument. Everything is the same until the task is called. At that point, Cn is not being passed into the task. Output argument means the task assigns the argument back to the caller at the end of task. So argument arc is still not at the beginning, and therefore this line is invalid. The argument needs to call new, then it can change the value of the object and passes the handle back to the caller at the end. Cn will then point to this new object, and this old Cn object will be released from memory. This is the same example but with a ref argument. Actually, most of the code's behavior is the same as input argument until the argument calls new. Because of the ref argument, Cn and arc are the same. When arc calls new and thus pointing to a new object, Cn will follow as well. When arc changes the object value, Cn will know about it. Similarly, this old Cn object will be released from memory. Note that in our argument example is skipped because I think its usage is uncommon. Now the final example, let's say there's a class called cParent. It contains an int x and a C number handle Cn. Copying this kind of class is more difficult. We can copy all the members like this. We copy x and then we copy Cn, but this is a shallow copy because ca.cn and cb.cn are pointing at the same object. To perform a deep copy, we need to do it this way instead. Today we've learned about class pointer. In the next tutorial, we'll be talking about randomization.